everybody, and welcome to Tremco Live. I am Marcy Tyler. I am one of your hosts for today, and I'm really excited to be able to have two guest contributors or two additional hosts with me today, both John and Bob. John and Bob, welcome to Tremco Live.
Thank you.
Thanks for having us.
Before we get into the great content that you guys prepared for us today, I thought you might be able to let everybody know a little bit about yourselves and your industry experience. So why don't we start with John?
Yeah, thanks, Marcy. Yeah, I'm an architect to begin with, and I've been with Tremco Roofing now for nearly 25 years. And before I joined Tremco, I was a project architect for a firm in Chicago. And the reason I joined Tremco was that I was introduced to them through a school district I was working on, and they said, we don't care what you specify, but you got to specify Tremco Roofing, and it blew my mind. Like, really, why? And as the conversation went on, I ended up with a job. So, and it's been fantastic. I've been able to build a career and a specialty as an architect, and I spend my days partnering with design professionals throughout the country on all things roofing and building envelope. And it's just been a great career and a great time.
I love that. I guess I didn't know that you started off exactly that way. So that's pretty interesting. I learned something today. So how about you, Bob?
So not quite as long as JB, but celebrated my 10th anniversary at Tremco in August. I'm getting there. Prior to coming to Tremco, I was in architectural sales. I sold brick and stone products for a distributor here in Chicago, which is why I'm broadcasting from here today. Came to Tremco, also did architectural sales for the first few years. Then was presented with an opportunity to move into a partnership with a rep here in Chicago. So for about 3 roofing seasons, we worked together. I still serviced architectural clients, but during the roofing season, I was a roof inspector. So I was on roofs every day doing the quality assurance, making sure that the Tremco system was being installed per plans and spec. That opened up another door for me. I ended up moving into the technical department in early 2019. I was head of the department for a couple of years. And then last year, put me on this journey that I'm on now with sales operations and training. So it's been a fun ride, to JB's point. A lot of great people work with this company, and it's been a great place to build a career.
Awesome. Well, I'm really happy to be able to call both of you guys colleagues of mine, and certainly enjoy working with you both. Here specifically today, we're going to be talking about roof restoration. Now, if people didn't catch our program last week, I very rapidly blew through a bunch of opportunities on the rest of the building enclosure. So I'm happy to have some people here helping me with the content. So we got both John and Bob helping us this week. And I think they're going to kick it off with telling us a little bit about that roof restoration story. So Bob, why don't you go ahead and kick it off? He won the coin toss, right?
Heads it was. Yeah. Yep. You know, unfortunately in roofing, the mantra is exactly how you see in your screen. So for those of us that have worked in the field or are working in the field, you get phone calls and it's, hey, the roof is leaking, get your butt out here, let's go. And you drive to the site and you always try to approach it with an open mind, right? And a lot of times you will start by, you know, here's where the leak is inside the building, I'm gonna go trace it up onto the roof. You know, for argument's sake, let's say you end up in the field of the roof. And obviously there's no puncture or any kind of tear or anything that's causing the leak. And then you start your hunt from there. You look at what direction the deck is spanning, all these different things, right? The point is, though, is going back inside the building and saying, I've looked around and I've figured out that the leak is not coming from your roof, it's coming from somewhere else. Have a nice day, bye-bye. That typically doesn't suffice with building owners, at least the owners that we service, right? If you're looking for that higher level of service, it's not so much, it's not your roof, it's what is it then? And that's where we find ourselves as experts at Tremco, looking into all facets of the building envelope. And there's just a few, some of our projects here on the screen. You know, the one in the middle, if anyone's familiar with Rylam tube testing. So testing that particular wall, and that's actually a wall that I tested a few years back in Streamwood, Illinois. You know, you're trying to rule out all these possible scenarios. And sometimes that's really what it is. It reminds me, if you take your car to the mechanic, they usually start with this process of elimination, right? And they start with the least expensive things and they work their way up to the most, right? So it's not the battery, it's not the alternator, it's not the fuse box, oh, it's this. And a lot of what we do is exactly that. And I'm not trying to pass the buck here, but I do feel like, and JB, if you share this as well, that there's a fair amount of leaks that we investigate that are not the roof, and that's
Oh,
where
yeah.
these pictures came from.
Yeah, no, absolutely. And it's and then when I work with architects or consultants or engineers on roofing solutions, you know, I'm the manufacturer's rep for the most part in that kind of a context. But we partner on these things, and I love working with design professionals because it really does take a holistic understanding of building envelope pieces and parts, how they work together or don't work together. Because when we get into roof replacement or roof restoration or some other roofing project where we're involved in an existing construction context, oftentimes it goes beyond the roof. We bring in a sealant regimen to deal with all the sealant joints, or some of these pictures here, we're looking at you know, an eaves situation where that might be aged and developing cracks or craze cracking. That would want to be addressed. And I'm sure the design professionals on the call right now are beginning to, you know, understand how you put together a document set for this, the various specifications and details and descriptions in the set as we go beyond the roof to grab all those other things that can contribute to leaks in building envelope. It takes that holistic understanding of how buildings work and building envelope should work. And I got to tell you, from a personal standpoint, that's really kind of the fun of it. Because every one of these situations is different and unique, and it's to figure it out is a great deal of fun for us.
Yeah, exactly. And I love both of your comments about that holistic approach of trying to figure out what was the source and then, you know, working collaboratively together to figure out what that right solution is. As we go through the presentations and this discussion, I thought this is also very interesting that I've heard you guys talking about the whole idea of breaking the cycle that exists today.
Yeah, I'll speak to this one briefly and let Bob chime in. Actually, Bob created this slide, but it reflects a great graphic that really reflects, I think, where we are going with roofing. We'll talk about some of the reasons why. It used to be the patch and repair, keep it alive, patch and repair, and then replace it. And we budget for all these things. And it's very expensive to replace roofing. It's disruptive. Some of the supply chain issues we have now are making it very difficult to get to some of the components we use in re-roofing, namely insulation. So the industry is shifting and moving, rightfully so, to more of an assess and a patch and repair and maintain to get to restoration in lieu of replacement. And real quick, what we're talking about with the restoration is a full system approach, fully warranted approach, so that the existing roofing material goes through a proper diagnostic process, which we'll chat on. And then we apply a new roof system on top of it, fully employing the existing materials and existing roofing materials, completing that process and putting a full system warranty on it. So everything from the structural deck up is under a new warranty. And it's this wonderful solution for design professionals, also building owners, that is less expensive, less disruption, and also allows projects to happen on schedule, given some of the supply chain challenges we're encountering. Bob, this is your slide. I kind of talked right over your slide, man.
Hey, they're all our side. Me slide is shoe side. So, no, I think you're right on. Where really what we're talking about, even the kind of peel restoration back, we're talking about asset management. We're talking about building owners looking at their buildings through the lens of it being an investment and an asset, as opposed to just a system that may or may not be working. And that's what that image on the left is. It's someone who's in a building and they're not really paying attention. They're not well versed. They may not even understand what the value of that asset is. And that's a lot of times where that conversation gets started. Like, Mr. or Mrs. Building Owner, were you aware that to replace the roof that's on your building now costs, to JB's point, in today's dollars, with all that we're seeing? I mean, a built-up roof here in Chicago is well over $30 a square foot to replace. Single ply has flipped the $20 mark. I mean, huge, monumental numbers for replacement. So if you're in that cycle, first of all, it's inefficient, right? And you're basically just, in a lot of cases, throwing money after money after money, trying to get it to come back. And a lot of people are looking at it from the sense of this piece of paper I have, this warranty I have, says this roof should last 20 years. So that's how long it should last, right? Well, again, go back to the car analogy. Your car may have a 100,000-mile warranty. It's certainly not going to last 100,000 if you don't change the oil, do all the lubrication, follow the maintenance schedule. And the NRCA has been very clear and has written documents and white papers about maintenance. So I think once there's an appreciation for maintenance and how it can extend the life of a building, that's where you start to move over to the right. And I think to JB's point, the final piece of that is really, now that you understand what assets you have and what condition they're in, you can put together a plan to break that cycle on the left. That's the key. You have to have a plan.
Well, and I like that whole idea of, I mean, breaking the cycle. And we see that with different restoration items on the facade too, right? You know, if you're looking at worn out seals around your windows, right? How do we get more useful life out of those windows, that facade, and then of course your roof? But I think another key point that you guys mentioned is you need to do some work too, right? You need to do some maintenance and some patch and repair. So I know when we talk about that, there's lots of different types of roofs out there. Are they all, why don't you guys talk to us a little bit about those roofing types and if they're all in that realm of restoration?
Sure, I'll take a stab at it here. A lot of stuff on that slide, which by the way is recognized in code. So it's not like a special list. If you flip through chapter 15 of the IBC, this is what's going to pop out at you. And there's obviously pros and cons to each type of system, right? I've heard a lot of people say things like, you know, built up roofing is a thing in the past. It doesn't serve a purpose anymore. Well, maybe in certain parts of the US, you don't see a lot of new built up roofs going on, but that's just one market, right? And for those joining from north of the border in Canada, you see a lot of built up roofing going on in Canada. And you talk about extreme temperatures, especially temperature swings. It's like, well, why are they doing that? There must be a reason for it. I guess what I'm trying to say is that as you go down the list, there's no one roof system, in my opinion, that's better than another one. They all have their place. They all offer a wide variety of service life, warranted life, maintenance costs. There's lots of things to consider, right? And we talked a little bit about code that plays into it as well. I don't know, JB, if you want to take it from there.
Sure. Yeah, well, the code implications of, you know, you've got reflectivity. That's one that's in the energy code. Below climate zone 4, we need to use an SRI solution. That becomes a specification bit that we need to adhere to. Then there's, you know, the R values, of course, under the energy code, and on and on. The code certainly dictates in good portion what we're ultimately going to want to install, what the system wants to be, if you will. But it's also important to work with, I think, manufacturers who have a wide array or a wide spectrum of solutions. And that's one of the things that attracted me to the company I'm with now, is that there are a great deal of choices to make with the one manufacturer. So you really get a customized solution every time with that manufacturer. And it's not just us. There are a multitude of manufacturers out there who have a great deal of solutions out there. It's true of our Sealants group and other folks, because the solution really needs to be customized every time per code, per building, per setting, per context. Setup can dictate things. Is it a difficult roof to get to? There's a great deal of things that come to bear when we make these decisions. So I always talk to my architects. I'm like, you know, work with me, don't work with me. It's fine. Just make sure you work with somebody who gives you the kind of choices so you can come up with the correct solution for that particular scenario, not a widget off a shelf solution. It's so important.
I think that is, and I love how you guys both explain that. There's a lot of different choices out there. We want to make sure you're not being forced into one or another, but really choosing the one that's going to best suit your needs according to location, use of building, and of course, most importantly, code as well. Now, I know you guys have talked to me a lot about different ways that we're going to look at these roofs throughout their lives, and then also from a diagnostics perspective.
Yeah, I'll take a swing at this, Bob, and you can tell me, everybody, where I went wrong. Let's talk about restoration again. I love the concept of restoration because it gives us this big tool in the tool belt, really, to deal with existing roofing in lieu of replacing or restoring. And this is true for other building envelope components as well, as Marcy alluded to. But if we do it right, we employ all the existing materials under a new warranty. So as design professionals and manufacturers, we partner on these projects, and diagnostics of existing construction, in my humble opinion, is more important than how we restore a roof, because we need to find out the condition of the materials, if there's any wet material in that existing roof, such as the picture kind of right in the middle shows an infrared analysis and very clearly where there's wet material. Before we restore that roof, we want to take that material out, replace it in kind, and build a proper substrate to restore. We want to know if there's enough tensile left in the system, if it's a multiply asphaltic system. All this regimen we go through, and you can see the list on this slide, that literally is a summary of work we would use on any roof system, except maybe the tensile strength analysis. That's primarily for multiply asphaltics. But diagnostics, when you get into a restoration system, is the most important part of it, in my opinion. Bob, do you agree with that, or am I off in my own little space on that one?
No, you may be in a space where you are, but we're together, man. No, we're right on that. I think to your point, JB, how could anyone possibly go into a situation, and when I say that, like an existing building, and make a recommendation without knowing what the heck is going on with the building? You have to start somewhere. And the picture on the left, I mean, that's not Photoshop, that's real deal. You have a lot of gypsum decks here in Chicago. Gypsum does not like to be wet. It always starts with an inspection of the deck. Does the deck even have the capacity to do what it is you're going to recommend? Right? From there, it kind of moves into the middle photos you see there. I mean, you're basically doing a thorough inspection of the roof and being able to sit down with the building owner with a written report that says this is what has been found. Here's the facts, basically, and then help them or guide them down a path as to how to use those facts to make a decision. Because at the end of the day, the building owner, to the previous slide, has a lot of different choices, and one of them clearly is restoration. And I would say for those that are tuning in today that aren't familiar with restoration, it is a valid solution. I don't want to say in all cases, but in a lot of cases. There's some cases restoration is not the solution, right? And you could use diagnostics, actual data, to confirm or deny that. So we talk about this all the time in training class. It's kind of funny. You'll go and you'll meet with building owners, and right away they're like, oh, I need a new roof. And you just ask a very simple question, like, help me understand, why do you think it is you need a new roof? Well, a roofer came by and told me I need a new roof. And it was like, okay, that makes sense. I'm sure they had some kind of reason for doing that. What did they show you? What kind of reporting? What kind of data? They just said that. And that's obviously what we want to try to avoid. And there's a lot of great contractors out there. Don't get me wrong. Not every contractor is driving around in a truck putting roofs in dumpsters and putting new ones on, because they're not. But to just jump ahead to replacement is really short-sighted, especially today with all the technology that's available, all the means and methods. And to JB's earlier point, you may need to take a tough look at your timelines for completion, because if you can't get certain products for 9 or 12 months, now what do you do?
Well, and I think you've used the analogy before about vehicles, right? Like if you're going to go in, get your car fixed, you're going to start and start to figure out what's going to make sense. That's the same thing for your roof, and the diagnostics are certainly part of that ability to troubleshoot. I think you listed some tools here, or shown some visual tools of just that, your diagnostic capabilities.
Yeah, there's lots of different technologies. And again, there's a reason for that. I would question anybody who just says, we're going to use, like in the center there above tools, that's an infrared camera, most likely a mid-wave camera, and say that that's the only means we're going to use. Most means of diagnostics require what we call secondary verification, right? So you're using at least 2 tools to arrive at a conclusion. And I think there's a more detailed slide that we had in another presentation, so I'll just summarize it now. When you go on the roof, or when the technician goes on the roof with that thermal imaging camera, the thermal imaging camera doesn't tell them what's wet or dry. It tells them what's hot and cold. The assumption is that if it's hot, the insulation is wet, and that has to do with solar loading during the day. When the sun goes down in the evening, that wet insulation is retaining heat. So you've done a great thing. You figured out that insulation is retaining heat, but now you have to come back and you could either use a moisture probe like you see in the top right of the screen. You could use a non-destructive method like the Tramex that's all the way on the left. The yellow is a Tramex deck scanner. We call it a nuclear scanner. Don't let that scare you. That's the one in the bottom right there. What's nice about that device is you can see the little gauge on it. It actually tells you how wet something is, right? So every material inherently has moisture in it. Is that moisture 10 times, 20 times, 30 times above where it should be? So you use them together, and that's how you get to your conclusion.
Yeah.
What do you think, JB?
Yeah, no, I would go up a little bit higher in altitude on this slide. Say there's a reason this slide is dedicated to diagnostic tools to figure out if there's wet material on your roof, because that is the major issue we're really looking for. And in commercial roofing, low slope roofing, we typically have insulation between the membrane and the structural deck, or essentially the interior of the building. And that insulation can get wet, and if it does, it can be very harmful to the building. First thing that happens is when insulation is wet, it has no R value. It is useful from a thermal resistance standpoint. But then we have wet material in a building where that if it's left there, it could begin to degrade, structural components like Bob's point, gyp deck, steel metal components, tectum, even concrete over time through freeze and thaw. And then, of course, the last bit of that is if we leave wet material on a roof, we could develop the dreaded M word, right? Mold. There are three things that mold loves. The right temperature, something to eat, which is some organic component, could be a facer on drywall or something like that. So those two already exist. All they're waiting for is moisture. So if we have moisture that's sitting in the building and just sitting there and going on and on, then we're going to get mold, because mold spores are all around us all the time. So getting the wet material out of the building is so important to this entire approach in so many different ways. That's why we dedicate a slide to these diagnostic tools.
I had a leak in my basement this past summer, and it was just interesting. I think we're all very difficult customers when it comes to our own homes when you have someone coming out and taking a look at things. But, I was like, how are you going to diagnose, what's your diagnosis of why that's wet before we start fixing it, before he starts deciding how he wants to fix it. I want to make sure it's not going to continue to cause issues. I know you mentioned these diagnostic tools. There's a little bit more information specifically about the infrared here.
Yeah, and this is really important because there are infrared analysis, which Bob talked about, which reads heat differential, is a massively important tool to us in the roofing industry. It's also important to other facets of the building. Like we can read heat signatures, so it's important for folks who like have an electrical panel that's acting up. You can put an infrared camera on. Is it really hot? Do we need to address that? So this technology is very, very important to the building industry. So hence the Infraspection Institute. There's a professional organization that deals primarily with thermography. And they've been very, very helpful in kind of laying out how to do things correctly. In fact, I was just on their website last night, and they have specifications that you can download, and that can be very helpful to the design professional. But the one thing I would leave you with, and Bob touched upon it, is we really want to make sure we use the right operator, because reading thermography on a rooftop is very nuanced. Wind can change temperature. Interior temperatures can be very high or very low. A bit of duct work beneath a roof can change your reading entirely. So we need thermography readers or technicians who really understand how to do that sort of thing on a rooftop scenario. The Infraspection Institute provides certifications for that. So that's one thing. The other thing is a mid-wave camera. It's a camera that grabs a greater spectrum of light, for lack of a better description, in opposition to a long wave camera, which is a much more simplistic camera. Picture to the far left on your screen. Those are inexpensive, simplistic cameras. You can literally get one on Amazon that attaches to your iPhone. And it can be relatively helpful. But really the mid-wave camera is where we want to be, particularly for rooftop scenarios. Mid-wave cameras are much more expensive. So anybody who has one has made a pretty serious commitment to this type of technology, as opposed to long wave, which again are, I think right around $500 to $600. So just take the time, if you get into thermography or infrared analysis, to do a little due diligence on who's doing it and what kind of equipment are they bringing to bear. Important discussion to have.
Yeah, like most things in life, you get what you pay for, right?
Yeah. Bob, that's some of your work, I believe.
How did you know that was my handiwork?
Because you brought it up the last time we did this.
You can tell I buy all the good Ryobi stuff. No. So JB, you touched on this before. When you have multi-ply bituminous roofs with gravel surfacing, there is a best practice, if you will. It follows an industry standard, ASTM D2523. What you're trying to determine, long story short, is how much tensile strength is left in that roof. Among other things, you can see all the readouts and the results there in the center. But years and years and years ago, you can see it in the top right there, the MBS 55 study, don't quote me on this, 1977-ish. It was a report that came out and said 200 pounds of tinsel is like the bare minimum. In other words, if that roof on the left was tested and it falls below 200 pounds, which you could see it did here, it warrants a conversation about how much useful life is actually left in this roof, and does it make sense to extend the life of this roof for 5 years or 10 years, right? Maybe it doesn't make sense to do it for 10 years, right? So Marcy, I think you hit it right on. It's what are the needs of the building owner? Maybe they're going to sell this building. Maybe they're going to lease it to somebody. Who knows? You have to ask that question, but just know that there's testing involved because you have to have data to make good decisions.
That's right. Yeah, the only thing I would add to that is the ASTM 2523. If you get into the multiply asphaltic system that Bob's talking about, really has to happen with a manufacturer who knows what they're doing. That is a requirement to get into a restoration. So, and that's a good one. That's a good. You want that.
Yeah. Well, and to speak to this slide, let's say a roof is neglected, and you find out through diagnostics, which is what this is showing. You're able to, we call it triaging it, but you're basically able to prioritize roof sections. And I believe the slide after this too, Marcy, if my memory serves me correctly, it kind of shows if you don't nip some of these issues in the butt when you find them, what they could turn into. And it's most certainly not going to get cheaper. I can promise you that. So again, giving a building owner good data that they can make decisions with.
Yeah, absolutely. So these are some pictures of restoration in progress, and I'll try to walk you through this here a little bit. First of all, most often we restore a roof with a fluid applied roofing system. People go, oh, a coating. And no, not a coating. What we're talking about is typically it's a polyurethane liquid applied material. It can be PMMA, PUMA. I'm sure you may have heard some of those out there. Even in the Sealants group, as they use this for parking garages and other things. Long story short is that it goes down in a very high build application. The base coat is 32 to over 40 mils in thickness. And to give you a feel for what that is, because we're in America, we don't deal with mils so often, is that a penny is 50 mils. Okay, so we're talking about a heavy build application of liquid applied material. Then most often we lay in full reinforcement throughout the entire system, which is the picture on the upper right. They're back rolling the reinforcement into the base coat. Then that's allowed to cure. And then once that cures, then we'll come back and put down a top coat. Again, at 32 is over 40 mils of material, which is picture lower right. So at the end of the day, you've got a lot of waterproofing material on an existing system that was essentially waterproof. So we end up, after we restore, with a thickness of material that was greater than when we had ever started. So that's how we restore a roof. And we employ, like we talked about, all the existing insulation, the flashing details, and all that sort of thing, blocking, all that kind of thing. And this happens after we go through, after the very regimented diagnostics to make sure that it is indeed worthy of restoration for a full warranted solution, 15, 20, 25 years. So that's kind of the long and short of how we do this sort of thing. Bob, anything to add to that?
The only point I'll make, JB, is to your comment about the pennies, whether you're using different coins or number of sheets of paper, whatever your methodology is to determine how thick it should be, just know that there's a lot of variability there. And this is a discussion that you have with the building owner. There's different chemical technologies. You have acrylics, you have urethanes, you have urethane hybrids. There's all these different types of materials, and a lot of them do have solvents in them. So one of the wormholes I see people get into is like, well, the manufacturer said it's going to go down at, I'm just picking random numbers, 64 wet mils. So that's thicker than this other company. And then you point out on the data sheet, well, did you notice on the data sheet that it's only 80% solid? In other words, 20% of that 64 mils goes away. So in reality, what you thought you were getting isn't really what you're getting. So it's important to do your research and understand the material that's left on the building is what you paid for.
Great point. Great point.
Well, and I love John, you kicked it off saying, coating versus membrane versus waterproofing, right? So just there's a lot of misunderstanding, and that's what we just want to be able to have the opportunity to explain that, or even the percent solids that comes up a lot in the air barrier world. What is the percent solids? What's that mil thickness? What am I getting in the end from a durability that's going to protect my inner structure from water getting in? So all of those are key parts of making sure we have watertight structures. For timing today, this is a two-part series, so just so everybody knows, both John and Bob are going to catch up with us next week. So we thought we'd close off today with just kind of reiterating again, why restoration? So who would like to kick this slide off for us?
Bob.
Another coin flip? Come on.
Go.
Yeah.
Yeah, I think for those that are able to actually see the slide, for those of you that are driving, I'll rattle off a couple of them. But really what we're talking about here, again, back to the very beginning, is a philosophy where you use tools and testing to understand the condition of your assets. You use that information to decide what to do with those assets. And it's not always just repair it or replace it. There's one right in the middle called restoration. It's a viable option for a lot of roofs that are out there. And whether it's because of, we talked about disturbance to building owners, tearing a roof off comes with a lot of disturbance. I think about my wife, who's a school teacher. They do those projects during the summer when there's no kids there. School is still filled with teachers. It creates safety issues in a lot of cases. The other thing that obviously stands out there is because you're utilizing all the existing accessory assets, I'll call them, like insulation, cover boards, substrate boards, vapor retarders, it costs significantly less than replacing a roof. Right now, with what's going on in the market, I'm seeing 40 to 50% in savings. So that window is kind of tightened up even a little bit more. And typically on restoration, it's a 50-50 split, material and labor, versus on a replacement, it's usually about 70% labor, 30% materials. What are your thoughts, JB?
Yeah, no, that sums it up, Bob. I think that's got it. But the only thing I would add is that restoration also has what I call this really wonderful sidecar narrative, and that's about sustainability. We're leaving existing materials in place, and they're performing much longer than originally conceived of or warranted, for that matter. So I tell my architects, I'm like, listen, we can talk about vegetative roofing, we can talk about solar panels, but there's nothing more sustainable than keeping building components working and performing much longer than initially thought they could. So to me, there's nothing more sustainable than restoration of any building component, for that matter.
Excellent point there, John. And obviously, Bob, lots of great comments there on why restoration. I talked to a design professional a couple weeks ago, and he said we need to make sure our envelopes are functioning as best as they possibly can before we start looking at other means and methods like photovoltaics or whatnot. So definitely lots of great information here. Lots more to come. We're going to get into installation. We're going to talk a little bit more about how these sustainable savings are here, some challenges, and just a lot more information. So don't forget to join us next week. Same time, same location, same co-host, where we get a little bit further into roof restoration. So thanks, John. Thanks, Bob. Thanks, everybody, for joining us. Everyone have a great weekend.